Okay, no problem. So mix-up attacks are an attack class where the attacker tries to steal an authorization code or an access token. And the basic idea behind all these attacks we classify as mix-up attacks is that the attacker tricks the client to send the credentials, so the authorization code or the access token, depending on the grant we are in, to an authorization server that is controlled by the attacker instead of the honest authorization server that these credentials are intended to. One important precondition is that the client supports multiple authorization servers, obviously, otherwise it couldn't mix up these authorization servers, and one of them must be controlled by an attacker. This might sound like a pretty strong precondition, but keep in mind an attacker could, for example, compromise an authorization server that is already registered at the client, or could use dynamic client registration to register a new authorization server to the client. As I said, mix-up attacks are an attack class, actually, so there are different variants using different additional preconditions. There are variants for the code flow, for the implicit flow, and there are also variants for OpenID Connect. And in the following, I will briefly introduce one specific variant. This variant, oh, sorry.
Yeah, keep going.
Yeah, this variant has the precondition that an attacker can actually manipulate the first request that is sent to the client. So this flow starts right here. The victim wants to start an authorization grant and selects this HAS, so the honest authorization server for this grant, but the attacker can manipulate this request here before it reaches the client and changes this selected authorization server to his own authorization server, the AAS. Afterwards, the client stores this AAS as the selected authorization server because when the request reaches the client here, it states that the victim selected the AAS. The client now issues the regular authorization request, as we all know, and this request is sent as a redirect to the attacker's authorization server. What the attacker can do now is either, as it is shown here, issue another redirect and forward the victim to the actual honest authorization server. He just needs to change the client ID so that the correct client ID for this authorization server is used, or as the variant is described in the BCP, he could manipulate this first request right here. But yeah, it's basically the same either if he manipulates this request or if he just issues another redirect. The fourth step here, the victim accesses the HAS, so the honest authorization server, and it will give his consent because remember the victim selected this HAS in the first place. So from the victim's perspective, everything works as intended. Afterwards, the HAS will issue the authorization code here in the authorization response and send it back to the client. And the client will now basically mix up the authorization servers, will make the mistake and issue the token request to the attacker's authorization server because here in the beginning, the client stored that this victim wants to use the AAS, so the attacker's authorization server. This means in the end, the client sends the code to the attacker and the attacker can, for example, use a token injection attack or some kind of attack to access the victim's resources and to read this code later. So how do we defend against mix-up attacks? Daniel?
Yeah. So how do we, what can we do against mix-up attacks? The first the discussions around what to do against mix-up started at the 0th OAuth security workshop in Darmstadt, which was actually held in response to the discovery of the mix-up attack by a team of the Ruhr University in Bochum, to which also Carsten is related, and by a team from my former group at the University of Trier and later at the University of Stuttgart. And in these discussions and in all discussions that you have with people around mix-up, the first question is always, do confidential clients help? And second question is always, what about PXE? And I will go into the details of these mitigations or not mitigations, and the per AES redirect URIs and the ISS parameter in the following. But it's important to note that in the past 4 or 5 years, we have gathered a lot of practical experiences with these defenses. And this allowed us also in the document that we're presenting today to refine the security considerations around the parameter, and also think more clearly about what threats we can defend against and which one we maybe cannot defend against. Okay, next slide, please. Are confidential clients safe? No. So in the mix-up attack, if we are in the authorization code flow, the attacker can steal an authorization code. And usually one would assume that if you have just stolen a code, but not the client credentials, it can be very hard for an attacker to redeem that code for an access token, or impossible. However, this is not the case. We have shown also in the paper that we wrote on the mix-up attack that you can do what we call the code injection attack, whereby the attacker starts a second session between or OAuth session with the client and the honest AS, controlled by the attacker, and the attacker takes the code from the first session with the victim and injects it into the authorization response in the session under his control. And this means that the client in the second session will use the authorization code, will redeem it using the client's client credentials, and the attacker then has a client that uses the resources or makes available the resources of the victim. So confidential clients are not safe against mix-up attacks. Next slide. Does PXE help? This was something that was discussed very intensively on the first or 0th OWASP security workshop. The answer is no. PXE does not really help against the mix-up attack. Maybe it makes the attack more complicated. In essence, the attacker can do the same attack as before, so the code injection attack. However, to defeat the protection provided by PXE, the attacker needs to convince the client in the second session to use the same code verifier that is valid for the code stolen from the first session. And to this end, the attacker can take the code challenge from, or can start the second session first before the attack, can take the code challenge from that session and inject it into the authorization request in the first session. Remember that in the mix-up attack, the attacker has control over the contents that end up in the authorization request, and therefore the attacker can modify the code challenge in the authorization request in the first session. And therefore the attacker can produce a code that is valid also in the second session because it uses the same code challenge the client, the attacker is using in the second session has chosen. So the attacker needs to start the second session first and then in parallel run the attack, but it's definitely doable. So PXE is not a proper protection against mix-up. Next slide, please. If we look at the core of each of the variants of the mix-up attacks, we see one common thing, and that is that the authorization response always comes from the honest AS, which makes sense because the honest AS produces the credentials, the authorization code that we want to steal as an attacker. So we have this thing that is constant, and that is always this authorization response coming directly from the honest AS. And we can leverage that for a better protection against mix-up. Next slide, please. And the idea that was discussed also very early on is to add something that identifies the source of the authorization request to the authorization response, whatever that is. So with existing mechanisms, and this is the recommendation that we still kind of give today, and that is with existing mechanisms, clients can do the following. Clients need to register a separate redirect URI at each of the authorization servers they're using. And the authorization server ensures that each client can, or when a client is redirected back, the authorization server checks the registered redirect URI against the one in the authorization request and makes sure that they match completely. So there are no variable parts. If there would be variable parts, this might undermine the protection because the redirect URIs for each of the separate AESs might just differ in a URI parameter, for example. And then in the last step, the client matches the redirect URI where it received the authorization response with the redirect URI it has created for the authorization server it expected would be used in that flow. And if there is a mix-up attack, there would be a difference because the in the example we've seen, the authorization response would be received by the on the redirect URI for the honest AS, but the client would still think that the attacker AS is in use in that flow. So there would be a mismatch and mix-up can be detected. However, next slide, please. There are several downsides to this approach. First of all, it just requires a lot of explanation to clients on what to do and what not to do. And the client need to think about how to encode and manage authorization server identifiers, how to match the redirect URIs, how to set up multiple redirect URIs maybe, and so on. So there's really a lot of work at the client side, and clients maybe not necessarily understand why they would need to do that. Also, the solution has a couple of subtle pitfalls. For example, the redirect URI, so the variable part of the redirect URI, must be unique for a combination of authorization endpoint URI and token endpoint URI. This is because an attacker might give a configuration to the client which consists of the authorization endpoint URI of an honest AS and a token endpoint URI controlled by the attacker, if we're not using OAuth metadata here. So the redirect URI must be unique for this combination, not just, say, for the authorization endpoint URI. It must encode the whole tuple. Also, this problem, the solution is not really suitable for ecosystems with centralized registration, client registration. We see that in the Yes ecosystem, where we have one registration and the clients can use several authorization servers. And of course, if you only have one registration, you only have one redirect URI you can register. And finally, we found that this mitigation can be circumvented. For example, if there is dynamic client registration, an attacker, AS, can modify the redirect URI that it gets from the client, that it receives from the client during the dynamic client registration, and send back a value that is the same one the client uses at an honest AS. And this is possible because during the client registration, the AS can modify the values and sends back what has been registered in the end. And depending on the client implementation, the client might actually use these values returned from the AS. So a malicious AS can influence the redirect URI at the end of the day. And also I found that if you combine the mix-up attack with a client impersonation attack, the attacker can essentially run a mix-up attack, because the attacker can, so if we look back at the mix-up, or if we think back at how mix-up works, the idea is that a client uses a separate redirect URI for each AS. But if the attacker creates a new client impersonating the honest client, the attacker can give or can register any redirect URI for this client at the authorization servers. And of course, this redirect URI can also be the one of the attacker AS. So when the real authorization response comes from the honest AS, it might use the redirect URI for the real client, but for the attacker AS, which the client would expect in that moment, and the client would not detect the mix-up attack. So a lot of small and some bigger problems here. And we found that really the only robust solution we could come up in all these years is the ISS parameter. And Carsten will now go into the details of that.
Yes, what are we actually specifying in our draft? First of all, obviously the ISS parameter, and this parameter contains the issuer identifier as it is specified in AS metadata RFC 8414, and adds it to the authorization response. Here you can see an example. We all know the code and state parameter, and we simply add a third parameter here, the ISS parameter. And yeah, as you can see, it's just the URL encoded issuer identifier of this example AS. And what this actually does is, as Daniel described at the beginning of the countermeasures, it reaches our goal to allow the client to determine who issued this authorization response. What we also say in our draft is that any AS supporting the specification must add the ISS parameter to all authorization responses. This includes error responses. So here you can see an example of an error response. Again, you see, again, you see the, you see the parameter is simply added as a third parameter, and this way a client can also recognize when the when it receives an error message that it was actually issued by the authorization server the client thinks he's interacting with. What we also specify in our draft is how the authorization server provides its issue identifier. First of all, it must always provide an issue identifier simply to give the client a value he can provide, he can compare the ISS parameter to. And there are two possible scenarios. The first one is the easier one. The AS supports metadata. Then we say this ISS parameter must be the same identical value than the issue identifier specified in the metadata. And the AS may additionally provide this identifier by other means, but this is not in the scope of our specification. And the a little more complex part is what happens if the AS does not use metadata. We believe it's a deployment-specific decision how to provide this issue identifier, but we mandate that an AS must provide any way for the client to get the correct issue identifier, for example, using a static configuration page for client developers that simply states the expected issue identifier for this AS. From the client side, the client must obviously compare and validate this ISS parameter. It should extract the value of the ISS parameter when it receives an authorization response and compare it to the issue identifier of the authorization server where the authorization request was initially sent to. If these parameters do not match, then the client must reject the authorization response and simply abort the authorization grant, because either there has been some kind of error or actually a mix-up attack we want to prevent here. The same aspect from the client side, as I said before, if the authorization server does not use metadata, we mandate that the client uses some kind of out of the scope way to configure an expected ISS value, for example, statically configure for each authorization server one value that this client expects in the ISS parameter. And the last important aspect for a client is if there are multiple ASs trying to use the same issue identifier, for example, during dynamic client registration or during the static configuration, the client must also prevent this, because otherwise an authorization server controlled by the attacker could simply use the same issue identifier as an honest authorization server, and this would obviously bypass the whole countermeasure. What we are also specifying is a new authorization server metadata field, the authorization response ISS parameter supported field. And as you can see, it's simply a Boolean value that indicates if the server supports our specification or not. And this allows the client to know if he can expect the ISS parameter in an authorization response or not. Okay, let's have a look at the security considerations.
So first question, is this secure? So most likely, yes, I would say. We incorporated the ISS parameter into our original OAUTH formal analysis paper. And in this paper, we have shown through a formal analysis that within this model, the OAuth is secure against mix-up attacks. As usual, the usual disclaimer applies. Models make certain assumptions, and also some simplifications, of course. But so far, we have not seen any major problems either with the model or with the ISS parameter mitigation. So we are quite confident that this should be a robust solution. Then the question is, should the ISS parameter be integrity protected? Of course, you can integrity protect the authorization response using JARM. But the good thing is that in all the mix-up variants, the authorization response, as I said before, comes from the honest AS directly. If there would be any possibility for the attacker to tamper with the authorization response, then of course the attacker would also be able to read the authorization response, and the attacker would not need to run a mix-up attack in the first place. So we can assume that the attacker cannot read or modify the authorization response, and therefore it's fine to put the ISS parameter into the authorization response without any, say, signature or the like. We also have thought about how this correlates with the ISS parameter that's already there in JARM or OpenID Connect. And we have specified in the paper, in the draft, how to handle that. If the issue identifier is already included in the authorization response, say via JARM or OIDC, then the ISS parameter may be omitted. This would be the case, for example, for in the OpenID Connect hybrid flow, if you use code ID token response type, or of course, if you use JARM. If, however, there are multiple issue identifiers, then the client must reject the response if these identifiers do not match. This is just a sanity check. And as you might know, if JARM is used, then the ISS parameter must not appear in the authorization response, but that is something mandated by JARM itself. How do we put this into the bigger picture with the security BCP? As you know, we discussed this in earlier meetings. The security BCP right now recommends the per AS redirect URI checking. But while writing the respective sections in the security BCP, I noticed how many things you need to explain for clients to implement this correctly. And this also gave some even more motivation to write the draft we're looking at today. So the idea is to really make this ISS parameter or OIDC ISS or JAM or something similar, make it more prominent in the security BCP. And I'm working on updating the respective section in the security BCP, and I will provide a new draft or proposal for that soonish. So we have implementations of the ISS parameter already. One is in the YES ecosystem, where we are using ISS because we have the central client registration. So we cannot use per AES redirect URIs, and we have not seen any problems with this implementation so far. Also, there's support in Connect to ID since version 10.2. And I'm reading right now that Dominic Bayer has checked in the support for the ISS parameter today, which is very nice. So thumbs up. Also, we have got positive feedback from other implementers, but these are the implementations that we know of right now. Carsten, do you want to do that? Last slide.
Yeah, thank you. We would like to discuss the next steps, obviously. From our perspective, we got some feedback on the mailing list, which we are thankful for. And I think we incorporated that feedback and addressed it in the right way. And yeah, we would like to see the draft adopted from the working group so that we can move forward with it and obviously get some further feedback from you and the mailing list. And correct me if I'm wrong, Daniel, but I think we are at a pretty defined stage already. As Daniel said, we got positive feedback from implementers, and some implementations are already in place. So we believe that there shouldn't be huge concerns, and we should be already on a good way.
Okay. Thank you, guys. That was great. So just one comment before getting into the discussion here. So I see we have more than 20 people here, or 20 people on the list, but the names in that link is much less than that. So please go and add your name to the list. Make sure we capture all of the people that attended this meeting. If you have any comments or questions, can you please add yourself to the queue, and let's have that discussion. Any questions first? Comments? Okay, I see really quiet group now. So can I ask how many people read this draft? Can you please? Can you please add +1 if you read this draft into the chat? Can you do that, please?
This is Takahiko Kawasaki from OAUTH Inc. And I've implemented that specification and confirmed that it works as expected.
Okay.
And yes.
Okay, thank you.
Thanks, good to hear.
Okay, awesome. Okay, good. So I see a number of people that have read the draft. So any questions, any comments on what you've seen so far?
Hi, okay. And this is Taka from OAUTH again. And I've implemented the specification, but the change has not been merged into our product yet. It's mainly because the conformance suite needs to be updated, because it seems that the current implementation of conformance suite rejects error responses when the ISS response parameter is included. This is because the ISS parameter is not recognized as a known parameter. So, but if this specification is not adopted as a working group draft, it is difficult for the certification team to update the certification conformance suite. So I hope this specification is accepted as a working group draft as soon as possible.
Yeah. Okay. We'll call for that in a second. Justin?
I just wanted to point out from that part of the fallout of Taka's point is that this is something that I think we need to get a feel for what all of the corner failure cases are for this. With Pixie, we need to figure out sort of hands-on, like what happens when you don't, when you are expecting the parameter but don't send it, versus when you're not expecting the parameter and you do send it. Like, what are the ways the failure modes collapse? And this is one of the cases where it is legal to reject somebody using this extension if you're being particularly strict with some of this processing.
Okay. Okay. Thanks, Justin. Dennis?
Yes, I have not considered all the possibilities in the draft, but I read it. And in fact, it is pointing to the document about security topics or security topics. And in this document, it seems to be a solution, and I'm wondering why this solution is not discussed in the draft. If you check the client ID, and it is explained on page 19 and 20, then the client may detect that the client ID has been changed, and then might detect that without using the ISS parameter.
Maybe I can answer to that point. If you would use that as a detection mechanism for mix-up, the assumption would be that the client has a different client ID at the authorization server and at the honest AS.
Yes.
In order to differentiate between the two cases. However, the client ID, especially the client ID the client has with the attacker AS, is defined by the attacker. So it can, in particular, be the same client ID the client has at the honest authorization server. So this is not really a defense.
Okay, well, I would recommend maybe that you gave that explanation in your draft. Could be useful.
Yeah, I'm wondering why it is in the security BCP, and I will check that there.
Which, once again, 19 and 20.
Yeah, I will check. Thanks.
Thank you.
Okay, thanks, Dennis. Okay, anybody else has any comments, questions? Okay, Vittorio.
Hey, I have to apologize because I haven't really read the thing, but so forgive me if the answer is already in the spec. But in the case in which you return access tokens that are structured, like what we describe in the profile, and in there we do make the is claim mandatory, would that allow the client, the source owner to check from where the issue is coming from? Or is this spec for the client to verify from where stuff is coming from? In which case, we don't want the client to look inside the token.
The latter. So this is the client checking the ISS.
The client. Okay, wonderful. So great, perfect. So feel free to ignore me. Thank you.
Okay, thank you, Vittorio. Anybody else has any comments, questions? I see some discussion there in the chat. Do you want to take it here or want to keep it in the chat?
Just a point. I don't believe any of the chat is captured as part of the working group notes or record. So
yeah,
if you want any of that to be included, please either add it to the notes or say it on the queue, and I'll do my best to capture bits and pieces of that as I can. Sorry to jump in though.
Yeah, good point, Justin. Thanks.
But maybe we can, for the benefit of everyone, like have Joseph and I think you, Justin, also talked about some things there. Repeat that because like we're not yet running out of time, right?
Yeah, we have time.
So I'm happy to say something about that. So this was just following on from Taka's point about the conformance suite. And Brian said, well, isn't that just a bug in the conformance suite? Which is a fair point. So I wanted to expand on that point. And this is about the OpenID certification and FAPI certification suite, by the way, for people who haven't picked up the underlying context. So what the certification suite is doing, as to the best of my knowledge anyway, is that it's raising a warning when people are returning a parameter from the authorization endpoint that the suite doesn't know about. So obviously it does that for the ISS parameter because the suite doesn't currently know about that. And obviously there's the background that servers are allowed to return anything they like from the authorization endpoint, and clients should ignore those things. The reason the certification suite just isn't is because we've seen implementations doing things that really should be brought to people's attention. I've seen error responses with authorization codes in them. I've seen error responses with the ID tokens in them. I've seen error responses with sub containing the user's user ID in them. And I'm pretty certain in all those cases, those things weren't intended and could at best lead to confusion in the future.
Okay, thanks, Joseph. Okay, anybody else has any comments, questions? Okay, so I get a good feeling here for it seems there is interest and people are kind of see value in this document. So I want to ask this team here right now if you are in favor of adopting this document as a work group draft. We will obviously take it to the list just to confirm it, but I just want to get the feeling on that from this team. So if you support adopting this document as a working group draft, please hold on. I think Brian has a question. Go ahead, Brian.
Yeah, I do support it. I don't even know how to say it. We had previously this document on the mix-up mitigation that kind of got loaded down with a bunch of other stuff, and just sort of is now expired and just out there. But this is, for all intents and purposes, sort of a subset of what was recommended in there. And I'm just wondering, like, process-wise, if we do indeed adopt this, which it sounds like we are going to, and maybe it's premature to even ask this, but either if this would replace that document, or if we could go ahead and put that document as like a tombstone or something, just to avoid confusion.
So is that a work group document that you're kind of talking about, Brian, or is that?
Yeah, I just double checked. I pulled up the working group page, and it's an expired working group document under there. OAUTH - mix-up mitigation, I think. And I'm not suggesting by any means that we revitalize it or anything, just just that we do whatever housekeeping would be appropriate to kind of make sure there's no confusion going forward.
Okay. Can you post the name of the draft to the chat there?
Yeah, I'll put it in the chat. Give me a minute to find it again.
Yeah, I think Torsten has put it there. If I'm
for your convenience.
Okay.
Torsten's
Thanks.
one step ahead of me as usual.
Yeah. Thanks, Torsten. Okay. Yeah. Oh yeah. Okay. That's an old draft. Okay. Okay. Yeah, we'll have to make a decision later on how to handle this. And Brian, thanks for bringing this up. It's a good point. Yeah. Awesome. Thanks. Okay. Again, if you support adopting this draft, again, I'm going to take it to the list. But for now, I just want to get the feeling here. If you support adopting this as a working group draft, please add your name or +1 here to the chat. Awesome. Perfect. Okay, good. I see lots of support. That's good. So I'm going to take it to the list and make sure we're, and when I take it to the list, please, again, reply there. This is just to get the feeling here, okay? So please reply to the list and just, we'll take it from there, okay? Okay. So I think that's it for us. Like Daniel, anything else from your side, guys?
Nothing to add from my side, Carsten.
Okay. Carsten?
No, nothing to add.
Okay, awesome. Thank you, guys. Anybody else has any comments, questions before we drop here? Okay, awesome. Good. Well, thank you very much, guys, and see you around.
Goodbye.
Bye.
Thank you, guys.
Bye.
Bye.
Bye.